You do. One of my least favorite sections. All right, laws of probability. Here we go. So some of the stuff that we will talk about today, we've already done actually. We've already done some of these things, except for we are going to give formulas to some of the things we've already done. So there's going to be a lot of formulas. So we'll talk about using those. Then we'll also talk about how we've already done the stuff without formulas, like it's okay. Go ahead and get your stat box. The title, like I said, is Laws of Probability for 22I. Yes.
We're about to take a test on probability.
Next week. I want to talk about it after the notes. So the addition law of probability was actually on that last quiz that you guys took last week, even though we didn't use it in law form. I tried to explain it in words. I'm going to use the picture to explain it as well, but in order to find the probability of events A or B occurring, that's the union, we have to add the probability of A to the probability of B, but then we must subtract the probability of A and B. Apparently I wrote the word instead of the letter. So the thing is, if we add A plus B, what happens is that overlap gets added twice, so we have to subtract one of them out, which is all it says here in a formula. The probability of the union, so A and B, is equal to the probability of A plus the probability of B minus that overlap piece, the intersection. Because A is all of this, and B is all of this, so if I add them together, this middle part gets counted twice. We don't want to count that middle part twice. That's why we have to subtract the intersection part. And then it also just gives it in words again, like a words and symbols combo. You will have a few questions on your assignment where you have to sort of just like solve equations. Like they give you values for the formula, you plug it in, you have to use your solving equation skills to figure out what's what. But a lot of the stuff you don't have to use the formula to do. Like we could, but we don't have to. I know there's a lot of writing. Keep in mind, a lot of it is, out of the textbook as well. All right. So then, just related, if I have a disjoint event, if these events are mutually exclusive, we don't have any overlapping part. So we don't have to worry about subtracting the overlap because there is none. So because the intersection of A and B equals 0, there's nothing that overlaps, then we just have the fact that the union of A and B is just A plus B. So just kind of adjusting that formula for when we don't have anything in common, any overlap. So then conditional probability is something we did actually talk about when we talked about tables, where on the table example we had people that went to university and people that didn't, people that were employed and people that weren't. And we had to figure out, like, given that someone was employed, what are the chances that they have a job? Or, no, they went to university. There we go. So that's what's going on here with conditional probability. So given two events, A and B, the conditional probability of A given B is the probability that A occurs given that B has already occurred. So what's new is this symbol, which is this little vertical line. This reads as A given B. So this symbol is conditional probability. So what are the chances that they are employed given that they went to university? So again, we've got some new symbols, but we've already figured it out. We've already done these types of problems. So in other words, what are the chances that A happens if B already did? And then in our symbol form here, the probability of A given B, we had already talked about back in section 22D that our denominator becomes not the entire population and the entire sample, but just how many people fit that criteria. So if we're still using that example, how many people are employed given that they went to university, this would be the total amount of people that went to university. And then this is that intersection, so how many people have a job and went to university. So even though those symbols look weird, we've already done that. Like, it's just in symbols now. So what if I switch this up and I said, what's the probability of B given A? On top we could have the same thing because that's where A and B overlap. But what would I divide by then?
Probability of A.
Yeah, the probability of A. So just something to keep in mind. The next three, what we have are these same equations, but solved for the intersection. So if you know the conditional probability and the probability of B, you could find the probability of that intersection happening. So they show both ways here. So this is just if I would have multiplied by the probability of B, I would end up with this equation. So it's just the same thing but rearranged. So a lot of equations, I'm going to talk more about them at the end of the notes. What we're going to do next is kind of get to an example where you can either use equations for some of them or you don't have to. So in a group of 150 students, 83 are in economics, 62 are in American government, and 28 are in both. So what we're going to do is we are going to make a Venn diagram to figure out how many students are not in either class. I'm switching something up really quickly. So have you guys started your Venn diagram yet? No, seriously. I just thought of a way to make the next example question better, so I just quick changed it. So we have to, make our overlapping circles here. One for econ, one for American government, That box represents the entire sample space, all 150 students surveyed. So how do I start filling this out? Now, this is what we talked about on Tuesday, but I wasn't here yesterday to answer any questions, so it should be a nice review. What can I put on my Venn diagram right away? Well, the whole thing has to add up to 150. There's not exactly a spot to write it. But I know that 28 are in both, so I can put 28 right away in that overlap. So then, if there are 83 students in econ, how can I figure out how many are just in econ but not in American government?
83 minus 20.
Very good. 83 minus that 28, that'll give me just the econ students that are not also in government, which should be 55. Reviewing from Tuesday. And I can take that same approach for government. If I take 62 minus 28, I end up with 34. So there's 34 students that are only in government, not also in econ. Are there questions about that? So how can I answer this question? How many are not in either class?
150 minus all 3.
All right, yeah, we've got 150 students total. So if I subtract the 55 students in econ only, the 28 students that are in both, and the 34 students that are only in government, what I have left will be the students not in either class, which I believe comes out to 33. So we're going to use the Venn diagram to find two probabilities, and that we can do it sort of by hand, or we can do it using like the formulas. Are there any questions about how we got any of this? Okay. So what if a student is randomly selected, find the probability that the student is in econ or government or both. So what do you want me to show you first? Using the formulas or just using the Venn diagram? The formulas? All right. So when we think about the formulas, and when a student is in econ or government or both, that is the probability of that union. So that first formula that we got said that the union is equal to the probability of, well, I'm going to use E instead of A, plus the probability of A minus the probability of that intersection. Keep wanting to put A first. Oops, again, that intersection is an upside down U. So that's the first formula that we had. So the econ would be, it was, let's see, going back to the example, it was 83. The American government was 62. Notice I'm over 150 because that's the total. And then the overlap is 28. So I add up all the econ students and I add up all of the American government students, but I subtract that overlapping piece. And since I just made up that example, I better do this one too. 117? So 117 over 150. So that's using the formulas. personally, I think the other approach is easier because what I would do is I would be like, oh, well, that's 55 plus 28 plus 34, because that's the econ, the government, over 150. So 55 plus 28 plus 34, sure enough, 117 over 150. So I'm not saying you have to use the formulas. You will have a couple of problems that will make you, but on problems like this, you can go the formula route, or you can just use your Venn diagram to figure that out. Okay. We got one more, but are there any questions about this other one and like both ways to do it? We ready for the second part? All right. So then a student is, what's the probability that a randomly selected student is in American government given that they are in econ? So we are going to use our symbols, American government, given that they are in econ, using that little vertical line. So then the probability using the formula was that the probability that the intersection, so the intersection of government and econ, divided by the probability that they are in econ. So that intersection, remember, is 28, so that would be 28 over 150. And then the probability that they're in econ, well, the total number of students in econ was 83 over 150. So using what we know about fractions, you can see this ends up being much cuter when I multiply by the reciprocal. So I end up with 28 over 83. And this is where I personally think the formulas are kind of doing the most. I do, because if I wasn't using the formula, I would say to myself, okay, the total is econ. Well, I know there are 83 students in econ. And of those 83 students, 28 are in both, and I would do this. And that would be the amount of work I would show without using the formula. So, gotta show you those formulas just because you will have some that you do have to use, but if you've got a Venn diagram, you don't have to use that formula. Like, you can puzzle this stuff out using your logic skills, but I still need to show you the formulas. Okay. Any other questions? We're going to hit up the stat box and be all done. All right. So just a little bit of reflection. What do you think you like better, the laws or the Venn diagram? I'm a Venn diagram gal as well. All right. So just keep in mind that these are in your formula packet. We haven't looked at the formula packet at all, so I just screenshot your formula packet to just remind you. The probability of an event is right here. Keep in mind that is the number of times the event would happen over the total sample space. So for like that first question, we had 117 over 150 because the whole sample space was 150 and 117 students fit the description of econ, government, or both. Complementary events we had a while ago, they have to add up to 1. And then these 3 probability laws we talked about today. This last one will be what we talk about tomorrow. So they are in your packet if you do need them. And I just had a hint. 1 through 3 are those few problems where, yes, you do need to use the formula, but pretty much you plug in what you know and you like solve the equation. So don't stress about that.